Hi, my name is Sam Burnside and this is my science project. I wanted to do something with guns and so I decided on shooting accuracy. My hypothesis was that prone will be the most accurate and the most precise because it has the best foundation. But I proved in this experiment that is not always the case, because it might have been my worst shot in that trial or it might have been the best. Standing position is good for quick shots, but if you want accuracy and precision, I would go for a different stance, because this one has a horrible foundation where your elbows are in the air with nothing under them, and the only thing that's holding the gun up is your arms, and if you're not very strong, that's pretty hard. This is the most common stance and the easiest to get into. The sitting stance is fairly easy to get into. Your arms don't get as tired because both elbows are sitting on your knees. It has fairly good foundation because of that. The kneeling stance doesn't have that good of foundation, but it's better than standing because one elbow is planted on top of your knee. Your arms don't get as tired, but they will get tired from holding up the gun, and it's pretty easy to get into. The prone stance takes the longest to get into because you'll be lying on the ground. Your arms don't get as tired because they will be on the ground for your foundation. I measured my data in 3 different ways. The first is accuracy. On the right of my data table, I have my averages. And as you can see, in trial 7, prone is my most accurate. But in trial 5, kneeling is my most accurate. In each trial, there will be a different stance that'll be accurate. Next is precision. Precision is the groupings on the target. There is a difference between accuracy and precision. Accuracy is how close you come to the center of the target. Precision is the groupings on the target. I measured one side of the grouping to the other so that I would get the outer diameter. Next is points on the target. In this one, you want the higher the better, the higher the number, the better. Because in the center of the target, it's 10. Then it goes down to 9, and then 8, and then 7, and so on. So how I measured this was I looked at each shot and which section that they were in so that I could measure the points on the target. As I have said in the beginning of my slides, my hypothesis states that prone is the most accurate and precise out of all 4 stances. Accuracy is how close the shots are to the center of the target, and precision is how close the shots are together as a group. These are my targets: trial 7, 8, 9, and 10. In trial 7 and 8, I have standing, kneeling, sitting, and prone. As you can see, going down from standing to prone, the accuracy and the precision become tighter and better. In standing, the shots are spread out all over the target, which is to be expected because standing has no foundation, because both elbows are up in the air holding a gun, which is pretty heavy, and so the precision and accuracy is off. As you're going down, it gets tighter and more accurate. Now down here in prone for trial 8, the accuracy and the precision are much higher than the other targets because you have both elbows firmly planted in the ground holding the gun. So it's easier to focus on the target than standing. In trials 9 and 10, I did these on the same day. Trial 9, standing, kneeling, sitting, and prone. Same goes for trial 10. In trial 9, standing, the shots are really all over the target. Again, as it goes down from kneeling, sitting to prone, it becomes tighter and more accurate. In trial 10, I began getting tired for holding the gun for about an hour doing trial 9. And so my accuracy and precision were a little off. even in prone, but they were still more precise and more accurate than the other targets.